Okay. Yeah, so what I was saying was, it's only, if you look at the coordinate geometry note, the amount of theory that we covered, it might look like only a little, but a lot of the exam questions on coordinate geometry now you can do. So I thought it would be nice if we try out a few questions. You will build up your confidence. And that's why I didn't send the whole, I wanted to just do it in class. Okay, now, do you all have your booklets, coordinate geometry booklets with you? I'm going to show the question anyway on the screen, but if you have it with you physically, that would be nice too. So before we begin, before I show you what question I want you to attempt first, let me quickly summarize what we did last week. What we did last week was how we can find the intersection point of I'm trying to get of two lines. If I give you the equations of two straight lines, you can find the coordinates of the point of their intersection. Okay, and I said that. So how do you do that? By solving their equations simultaneously. And I said that has to actually, in coordinate geometry, this result is the most important result that you will take away. It's the fact that the intersection point of any two straight lines, a line and a curve, two curves, right, can be found by solving their equations simultaneously, right? So if I quickly discuss with you different cases in which when you think of intersection points of two curves or two lines or a line and a curve, different cases that they can be in. What I mean by this is, now think of two lines, okay? I give you the equations of two lines. Now, no diagram given, I just give you two equations of two lines. And I ask you to find the point of intersection. When you have two lines, would you always have an intersection point? Can there be no intersection point? Like, what are the different cases in which two lines could lie on a plane? When you have two lines, any two lines, do they always, any given two lines always intersect? What do you think?
Unless they don't have the same gradient, they will intersect?
Unless they have the same gradient, unless they are parallel. If I give you two equations of two lines that are parallel, you are not going to be able to find an intersection point because they don't have an intersection point, right? So, so there are like two cases. They could intersect, they could not intersect, they might not be intersecting, in which case you won't have a solution. When you try to solve them, you would see that you don't get any solution. That is because they don't intersect. There is another case, which is kind of like, you might think, is that even a case? But there is another case that can happen. I can give you the same line. I mean, the two lines coinciding on top of each other. So basically, it's the same line. So the equations would look the same, or I can scale up one equation by a certain factor. Say one equation is y equals 2x plus 3. The other one I give 2y equals 4x plus 6. I multiply that equation by 2. It's the same line. Then the second equation that I'm giving, though it looks a bit different, it's the same line. Then how many solutions do you have? Where do these two lines intersect?
They don't intersect?
They don't intersect. If they're on top of each other, they are the same line. They're intersecting everywhere. They're intersecting everywhere. There are infinitely many intersection points because they are the same line, basically. Okay, so that is a case too that can happen, but you won't get questions out of cases like that. you might be asked to find the intersection point, or to, if you get a case like this, there will be no intersection point. Right. Even for if you think of a curve and a line, so then you have to think what kind of a curve. Like if you have a parabola and a line, we saw this in quadratics. When you have a parabola and a line, there are three cases. The line could not cut the parabola at all. The line could be crossing the parabola at going through 2 points of the parabola, so that there are 2 intersection points, or the line could be just a tangent to the parabola. That means only one solution. So depending on how many intersection points are there, when you solve your curve equation and the line equation, or whatever the 2 equations, the number of solutions you would get would differ, right? So that is determined by at how many points they are actually intersecting. Right. So yeah, so what we are going to do now is I am going to show you, in fact, actually in your booklet, if you see, let me show you, the first few questions, all of them you can just do. They're all, a lot of the coordinate geometry questions are based on that little amount of theory that you did so far. Okay, so we are going to do a few questions today. Let's start. Okay, so you all have this book. This is the coordinate geometry book, right? So if you look at these diagrams I have given on the cover page, just have a look. I have included, like in the first part is how a point is given a pair of coordinates, and this is the intersection of 2 lines. And then these are different objects in geometry, but they can be given, and they can be given equations, even if you have a shape with different that is formed by the use of different number of lines or curves. Each line would have an equation. So everything in geometry can be related to algebraic equations. This thing we will discuss last. Okay, so I also have given the syllabus content on the second page, so you know what is there and how much more to be covered. And under coordinate geometry, there are no formulas. I mean, there are no formulas, so no formulas are given for coordinate geometry. Right, shall we start this first question? Now, let me tell you, now I still didn't, my last topic with you was intersection of 2 lines. But when I finished that, I said that this knowledge can be generalized into not just 2 lines, but any 2 curves. Okay, so in this first question, what you actually have is, if you see, it says the line x plus 2y minus 9 equals 9, that's a line, intersects the curve xy plus 18 equals 0 at the points A and B. So they say there are 2 intersection points. So this is a line and a curve, some curve. Would you know the shape of this curve by looking at the equation? No, because it's not something that we recognize. A quadratic function, you should recognize. The type of equations that you should recognize when you look at them are linear. This one, when you see that equation, you have to know that's a straight line. And a quadratic, a parabola, a quadratic function, the equation of a the equation of a parabola, okay, which would be a quadratic function. But this is none of that, right? So you don't know the shape of that. You don't have to know the shape of that curve. They say that this curve intersects the line at 2 points. The question is, find the coordinates of A and B. So you know what you're supposed to do. You have to solve these 2 equations simultaneously and expect to get 2 pairs of solutions, 2 answers for x, and for each x a corresponding y answer. So there will be 2 pairs of solutions corresponding to the 2 intersection points. Okay, so even though we didn't write a note about intersection of curves or intersection between a line and a curve, this is based on the same theory that we did last week. Okay, so you can do it. Can you try? Can you start? The thing is, I can't see you do your work, so I will I trust you that you would do it properly. If you were in front of me, I would like come and see your work. But if anyone wants to, if anyone can switch on their videos and like point towards your work. Can anyone do that? It would be nice. Anyway, so start please. I will also do slowly in the whiteboard. So let me copy this x plus 2y equals 9, xy plus 18 equals 0. X plus 2y equals 9. Xy plus 18 equals 0. So in order to find the intersection points, you know that you have to solve them simultaneously. And the substitution method could work. I mean, here, what's the easiest thing to do? The easiest thing to do is, since you have this x here, let me show you this x on its own without a coefficient, just x. So that's a nice term there. Make that x the subject from the first equation. Let us do that. From the first equation, if I make x the subject, so this is substitution method. You know what you do in substitution method. You make x or y, one of your variables, the subject from one equation, and then substitute that in the other equation. So x is equal to 9 minus 2y. Now I can substitute that. Let me call it 3. Let me call it 3. And then I can substitute that. Sub 3 in 2. Substitute 3 in 2. Excuse my bad, poor looking handwriting. It's because I'm writing on the screen. So what do I get? I'm substituting this in the second equation. So I will get, let me start that in a different color. Xy, so x is this, 9 minus 2y, x, y, plus 18 equals 0, right? Did you come to this point? Or have you gone past that point? I want you to be ahead of me. So I'm just doing, I will do it slowly. Yes?
Miss, do we get 2 possible points?
Afra, did you miss anything that we were talking? Of course, Afra, we talked about that. Read the question. There are 2 intersection points. We have to get 2 pair of solutions. Yes. I said that a couple of times.
Okay, Miss, I just heard it.
See, read the question again. They say the line this intersects the curve this at the points A and B. So there are 2 intersection points. So that means you are going to get 2 pairs of coordinates, 2 answers for X and 2 answers for Y, corresponding answers. Okay. So somebody's right. Oops. Okay. So then, so you get a quadratic, a little quadratic here, right? 9 minus, sorry, not 9 minus, 9y minus 2y squared plus 18 equals 0. So you have gotten here a single equation of a single variable, just y, and it's a quadratic. So you know that you're going to get 2 answers for y. You have to get, now you expect this, because they said already that there are 2 intersection points. And you can, okay, let me arrange this nicely. 2y squared minus 9y minus 18 equals 0. And you can use your calculator to solve this. Don't waste time, because there is a coefficient in front of the y squared term. You know you can use the calculator for this. Right? You know, right? One of your answers is 6, or the other one is minus 1.5. Did you get that? Minus 1.5. Now, how did I get this answer straight away? I used the calculator. Okay, I used the calculator. You can do it too, because solving a quadratic equation is not something they test you. They test you on in advanced level. Huh. Okay, Akitmi already has both pairs of coordinates. So I found the y coordinates first, then corresponding to each solution that I got for y, I can substitute back in one of my original equations and find the corresponding x's. Akitmi, I'm sure your answers are right, because you have the same y coordinates, right? Okay. Minus 3 comma 6 and 12 comma minus 1.5. Yes, that's right. Okay. How easy was that, isn't it? So this is what you get at the exam, advanced level. I want you to build some confidence out of this. Yeah, that's correct. The 12 comma. So if I show you, like, let me just finish my work, right? I have just done it halfway through. So how should it look like after that? So now I got my, so let me like box them. Here's one of my y coordinates and the other y coordinates. These are the two y coordinates of the two intersection points. Now, suppose, let me draw a little diagram. Suppose your curve is like that, and your line is like that. So there are two, no, this would have more than two intersection points. Wait, that can't be. Do you see that? Let me draw, say you have something like that, okay? So you have two intersection points here and here, but what you got here are the y coordinates, 6 and minus 1.5. So how do you find the x coordinate now? You substitute this back. So sub y solutions or y answers in which one can we, first one, right? First equation, or better 3, because in 3 I have made x a subject. So x is equal to 9 minus, when y is, let me say that, I'm just writing this out to model how your work should look like, okay? So you have to say when y is 6, this is when y is 6, x is 9 minus 2y, so that is that. That gives me minus, is that an answer? Minus 3. Then when y equals minus 1.5, x is 9 minus 2 times minus 1.5, that is 12. So finally you have to put your answers together. And now I'm running out of space here, but you have to put your answers together and say A, doesn't matter, A, they say that the two intersection points are A and B. So A could be minus 3 comma 6 and B could be 12 comma minus 1.5, right? That's how you finish. That was easy, right? Do you have any questions from that?
No, miss.
No, good. Let's go and check how many marks was that. 4 marks, right? See how easy that was. Okay, let's go and check out number 2. Even that you can do. So I'm showing you the question on the screen. If you have your booklets, you can look at your booklets. Let's read this. So there is a diagram given. This looks like a rectangle, ABCD. So they say the diagram shows a rectangle ABCD where, okay, now let me tell you. Now, these questions that we are going to do here, they're all based on the little amount of theory that we did. If I quickly recall back the first bit of theory 2, you learned how to find the distance between 2 points. There's a formula for distance between 2 points. Aisha. Aisha is asking, I subjected x in both equations and equated them instead of using sub. That's fine. You are free to do whatever. That's the beauty of math. I mean, as long as you do logical, reasonable, I mean, correct things, logical things, that as long as you are doing things that are not mathematically wrong, yeah, go ahead. So Aisha has made x the subject, but I think the thing is this, wasn't the way that I did easier than that? Because you already have x. It's easier to make it the subject and put it in the other one. You had to make, no, same thing, I guess, same thing. It's fine, okay? It's the only thing you have to know is, now let me say this. There are many ways to solve a problem. To get to the same destination, you might do this way, I might do that way, another one might do that way. You have to have the insight to choose. If I make which move, would this be faster or quicker or more productive, more like the best way? Because why do we need to know the best way? It's okay. You can do any. I mean, even if it's a long path to the destination, it's fine. But since we are going to sit for an exam, and an exam has to be written in a given amount of time, the speed is important. So you have to also learn how to choose the quickest way of doing things. Otherwise, any method that you do is fine as long as the method is right. Okay. Especially when you solve simultaneous equations, you can do so many. Another person could have made y the subject from both and equated them. Now, why did I choose to? Let me just quickly go back to that. Why did I choose this way? Why did I do this? Why did I do this? Because I spotted that there is an x, just the term x in one of the equations. So it's easy to make it the subject. It's easy to make that x the subject. And then it's easy to go and put it in the other. So Aisha would have gotten, she made x a subject from both. So then from the second one, you get a minus 18 over y. So that's a fractional term. I think, this is my perspective. You do it and see. I think this is the easiest or the shortest, maybe, okay? But I always encourage you to just have that freedom, do whatever that comes to your mind first. And while doing that, you have to learn to recognize the best method too, okay? Right, so coming back to this, you're welcome, Aisha. Coming back to this, so I was reminding you of that beginning little bit of theory that we did. We learned how to find the distance between 2 points. There's a formula to find the distance between 2 points. We learned how to find the midpoint of 2 points. We learned how to find the gradient of the line joining 2 points, and then to write the equation of that line, how to write the equation of a line in 3 different forms, 2 different forms, the slope-intercept form and the point-slope form. All that will be used in this, okay? So anticipate that. So this says the diagram shows a rectangle ABCD where A is this and B is this. Find the equation of BC. Find the equation of BC. Okay, BC. 4 marks. Find the equation of BC. Can you try? They have given the coordinates of A and B. A and B. You have to find the equation of BC. Um, can you all do me a favor? Can you all unmute? Oh, you found it already, Afra. Okay, let's see. Yeah. So you know that if you have the booklet, the answers are at the back. You can check. I have to like go up, swipe it up. Can you all unmute yourselves and just at least talk to me while doing this? That would be, because I can't see you, right, doing it. Like, can you think out loud? Let's discuss about it. If that is possible, I would like it if all of you unmute your microphones and just we'll discuss about this. How do we do this? Find the equation of BC. So again, no, I'll tell you. I'll let you try it first for a few minutes. So Afra has gotten an answer. No one unmuted.
Miss,
Yes, Aisha.
I got y equals x plus 11 whole thing over 2.
Wait. Y equals x plus 11 whole thing over 2.
Yes.
That looks correct. Yes, Afra got y equals half x plus 5.5. That is the same as what you said. So
Got the
should be
same
right.
too.
Yeah. So Afra and Tenum, who just spoke to me? Aisha, na? Yeah. So Aisha and Afra got the equation correct. Now others don't feel, this is the thing. Let me tell you this, okay? If you are taking a little bit of time than others to get to a solution or figure out how to do something, that is fine. That has nothing to do with mathematical thinking. Thinking needs time. It takes time. You have to spend time and think about it. How long you take for it does not matter. It only matters at the exam. That's why we are practicing how to speed up things. That is just for the exam. For math, that's not a requirement. You are supposed to take your time and just very leisurely and calmly, peacefully think about a problem and solve it at your own pace. Okay, so anyone who's taking a longer time than others, don't feel anything. You have to feel good all the time. Okay, there is no pressure. Just take your time and do it. Tenumi got the same thing. Okay, Tenumi got it too. Especially when people keep getting answers, and if you are a bit late to get the answer, it is completely fine. I can't emphasize enough on this, because this is something that can make you feel anxious about math when others are getting the answer and you're still not getting it. It is fine. Okay, Senitu has gotten, yes, Senitu, that is right. This is very good. So you all figured it out. Yes, Senator. Who else are here now? So four of you, Aisha, Afra, Tenumi, and Senitu. Akitmi got it too. Is that all we have today? Did 5 of you got it? Oh, Afra, you got disconnected? Nothing happened. No, you didn't miss anything. Let me check. I forgot who are here today. Afra, Akitme, Aisha, Senitu, Tenumi. That is it, right? Okay. So all 5 of you got it. Great. My goodness, I'm happy. So, so you first found the gradient of this, right? And these two are perpendicular. You turn it upside down. And did you all use? I'll tell you something though. You all have gotten your equation in slope intercept form, whereas you should have gotten it in after I saying, but teacher, in the answers part, of course it is given in point, because you are supposed to get it in points. Then naturally you get it in point slope form. Remember I told you, you always you have this mindset because you're so used to the y equals mx plus c form. You don't feel good until you have it in that form. Please, you have to get rid of that feeling. When you have a point and the slope of a line and you have to write the equation of that line, use point slope form. Don't waste time turning it into point intercept slope intercept form. Now all 5 of you gave me the answer in, check your answers. You got it in y equals mx plus c form. Now tell me, what was the gradient of the AB line? Wait, okay, now don't continue the question. Don't continue the question. I need to fix this right now because you have to learn this. I have to fix that. Now you, oh my goodness. Okay, so look at this. So you had, let me just draw this like that. This is B 1,6. This is A 3,2. You found the gradient of AB. Let me write like that, m of AB. So you did 6 minus 2 over 1 minus 3. That gives you 4 over minus 2. That gives you minus 2. This is a bad equal sign. And then you can find, A, B, C, D. You can write the gradient of BC. It is going to be the negative reciprocal of that. So it's half. Now watch how you are supposed to do this, okay? You're supposed to do it. Now you want to write the equation of BC. You want to write the equation of BC. You have the gradient, you have the slope of BC. And you have a point on BC, 1,6. This is, what are the two information you have? You have the slope, you have a point on that line. Use the point slope form. You can straight away write the equation y minus 6 equals half times x minus 1, and that is it. Can you all remember this next time? When in instances when you have the slope and a point on the line and you have to write the equation, you use the point slope form. Okay? So this is the way you should have done it. Now I can predict how you did it. After you got this, now let me show you how, after you found that, this is how you should have done it. You all have done, I don't have space. I will do it in a little box here. My box is run. Okay, I don't have space here. So let me do it in a little box here. Oops. Okay, you did, who's saying something? See, you expand, even if you do it this way, you would expand it and turn it into the y equal. Why do you do that? Akitme, so that is my point. This is a standard form accepted as the equation of a straight line. The equation of a straight line need not be always written in y equals mx plus c form. Can you come out of that? Can you all come out of that? You are stuck in y equals mx plus c form. Okay, I think this, and some of you would have done, so you put y equals, the gradient is half, so half x plus c. I have to now find c, and then you substitute this point 1,6 into this and found c. Isn't that how you did it? Okay, so
Yes, ma'am.
see, I know that. So please remember.
Yes, I got it in point slope form, but then I expanded it further and like simplified.
I know, even that's what Akitme has done. So you don't have to do that, okay? Leave your answer in point slope form. It is a form, just like slope intercept form, okay? Right, let's move on. So then it says, given that the equation of AC, that's a diagonal, right? The equation of AC is y equals x minus 1, so it's given. Find the coordinates of C. Ha ha. Ha ha. Does it immediately strike you what to do? You just found the equation of BC. They give you the equation of AC. Find the coordinates of C. What to do? Quickly tell me what to do. What is that point C?
Point of
Intersection.
Point of intersection of these two lines. Okay, find it.
Miss, I got 13, 12.
What comma 12?
13, 12.
13, 12. Okay, so that's the coordinates of C. 13, 12. Can someone verify that?
Miss, I got it.
Okay.
13,
13, 12. Okay. If anyone else is still doing it, it is fine. Take your time. Do it at your pace. It's fine. Okay. So let's see. Let's wait till everyone gets there. Or others can go to the next part. So I will just slowly talk about the next part. The last part is find the perimeter of the rectangle ABCD. Perimeter is the total length around the shape. So you have to, this is a rectangle, two of these and two of these. If you find the length of this, double that, find length of that, double that, and add all of that together. So you know how to find the length between the distance between 2 points. See how easy this is? And it uses all of your little theory parts that you did in this section. Senitu, Akithmi, did you get 13, 12 for C? Okay, good. Right, so the perimeter, so you can find the distance between AB and distance between BC, and then double each one because you have 2 of each and add. Has anyone found the length AB? What's AB equal to? So you need AB, you need BC, and then you can add the two and double it. Length of AB is AB. 6 minus 2 square plus 1 square and this. BC. What's the length of AB?
This for AB, I got 2 root 5.
Yes, that's right. Root 20, that is 2 root 5. 2 root 5, and Akit says 4.47. It's better if you can now. This is something you have to know. This is the importance of that pre-algebra that we did. Remember surds? You get a surd answer. You get root 20. You know it's an irrational number, and if you try to change that into decimal form, it's not exact. So you can just leave that answer as root 20, or you can simplify it to 2 root 5. So AB is 2 root 5. Length AB is 2 root 5. AB you get as to root 20. You know how to simplify this. It simplifies to 2 root 5. And length BC is how much?
6 root 5.
6 root 5. Is it root 180?
Yes, miss.
Yeah. So you get root 180, which can be simplified. I'm not showing you the steps of simplification. Hope you remember all this. That simplifies to what was it, Aisha?
6 root 5, miss.
6 root 5. 6 root 5. Okay. Then the perimeter of ABCD would be, you would add these two and double it, right? 2 times 2 root 5 plus 6 root 5, because there are 2 of each side. I'm having trouble writing 5 here, because there is a, can you imagine a 5 there? So you get, what is 2 root 5 plus 6 root 5? 8 root 5. 8 root 5. So 2 times 8 root 5, that is 16 root 5 units, whatever units. 16 root 5 is the exact answer. If you try to change the root 5 into a decimal number, that's not going to be exact. Okay, how many of you got this?
Got it, miss.
Very good. 16 root 5. Good, Afra.
I also got it, miss.
Okay, Aisha. Is that Aisha? Yes.
Yes, miss.
Senitu? Yeah, okay, great. How do you feel? How was that question? Was it like, from a scale of 1 to 10, how hard was that? For an advanced level exam paper question, how hard was that? That wasn't hard, isn't it? Okay. Easy, yeah, right? How hard was that for Akitmi? My question is, how hard was that from in a scale of 1 to 10? 1. That's very good, Akitmi. Yeah, right. Coordinate geometry is very easy, and it's because it's very. I mean, you can just it's just simple logic. You just think about it, and you can just solve any problem given within the theory that you know. Let's say the next one, third. Yeah, that's a nice question too. Shall we try number 3? See what a little amount of theory is used for this question number 3. It's 8 marks. But in terms of little pieces of theory that you learned, only a few are used here. Few little pieces of knowledge are used here. So the line L1 has equation this. They have given the equation of one line. The line L2 passes through this point A and is perpendicular to L1. Okay, now please remember what I said in the earlier question. If you happen to have a point and the slope of a line, and you have to write the equation of that line, use the point slope form, please. Okay. Do part 1.
Miss, I got y minus 4 equal half x minus 7.
Y minus 4 equals half. Okay, I already see the coordinates of point A, the 7 and 4 in that equation, which is good. And then if I look at that equation to get the gradient minus 2, correct. That's correct.
The same as Afra, miss.
Yeah, that's right. I mean, can you okay, can everyone pause your work for a bit? Stop your work, stop. Okay, look at me. Look at me. Now, okay, hands off your pens and books, right? I just want to show you, now this part 1 is 4 marks. That's a lot, okay, 4 marks. And you can even do this in your head without writing anything. If you imagine this L1, there is this L1 equation given. L2 is perpendicular to this. So you know the gradient of this is the negative reciprocal of the gradient of that. And you have a point. How do you figure the gradient of this out? You can do it. You don't have to do anything. That equation, rearrange that equation into slope intercept form by moving the 2x to the other side, minus 2x. So the gradient of L1 is minus 2. Gradient of L2 is, turn it upside down, change the sign, half. I didn't use any pen or pencil, no writing I have used yet. Then the equation is, you look at the coordinates here, y minus 4 equals half times x minus 7. You can just say it. This could have been an oral test. Do you see how that's 4 marks. Okay, go back. Now part 2. Given that the lines L1 and L2 intersect at the point B, find the length of AB. Again, another 4. This is easy, 8 marks. So first you have to find the coordinates of B. That's the intersection point of L1 and L2. And once you have the coordinates of B, it's a matter of just finding the length of AB is using that formula.
Miss, I
Yes.
got the length of AB as 2 root 5.
2 root 5. Let's wait for another person's answer. Can someone verify that? What are the coordinates of point B? Let's check that intermediate step.
B is 3, 2.
B is 3, 2. Did we get that, others? Are we getting that? 3, 2 for the point B. So you have let me just, okay, so you have to, if I just quickly show you, to find coordinates of B, intersecting point of this and this, you can make y the subject from 1, 8 minus 2x, then put that into sub 3 in 2, sub 3 in 2, you get 8 minus 2x minus 4 is equal to half x minus 7 minus 4. 8 minus 4, this is 4 minus 2x equals half x minus 7. If I multiply by 2, 8 minus, so I'm multiplying the whole, oops, I'm multiplying the whole equation by 2. It's windy here. X minus 7, I get 5x equals, I get 5x equals 15, x equals 3, yeah, x equals 3. And then if I put that in sub in 3, I get y is equal to 8 minus 2 times 3, that is 2. Right? So my point B coordinates are 3, 2. Got it now, others? I did it on the board because one of my students is thinking that there is a construction going on near the house because of this. It's because there is a lot of wind here, and there is a sheet that is like vibrating due to the wind. It's very windy here, very windy. The trees are like going crazy. Yeah. Okay. So, others, did you get it? So B is 3, 2 and the length AB length AB, I will just write the answer, is 2 root 5. Everyone got it, na? So Akitmi got it, Aisha got it, na? Afra got it. Tenumian Senitu?
Got it.
Got it, na? Yeah, right. How hard was that question? That's 8 marks. See how simple. You just need to clearly think what to find and what to use and just step by step do it. These are beautiful. I love coordinate geometry. Personally, coordinate geometry is one of my favorite favorite sections in math. Okay, I'll tell you. Now, so we did 3 questions. I will do, let's do one more, like this one, okay? And then we'll go back to the, go back to continuing the theory part. We have only a bit more. I think, yes, I think this is a nice question. So even number 4 is not bad. I mean, look at number 4. Find the coordinates of the points of intersection of the line this and the curve this. I mean, let me leave that for homework. Maybe number 4 for homework. So straightforward. 4 marks, easy 4 marks. Number 5, since there is a nice diagram, shall we try that? And then we'll continue with the theory. So this, I will completely leave you to handle. I will not say anything and let you do it. Don't worry about the speed, okay? Do it with understanding. Don't rush. Understand, read the question well, properly understand what's going on, and do it slowly and get it completely right. That's all I want you to do. Get it right. Speed we can practice later. Okay. Start. Number 5.
Miss,
Mm-hmm.
Miss, for BC, I got y minus 6 equal half x minus 4.
That's for BC. Y minus, so you see the coordinates of B are 4 and 6. So I can already see, I just need to check whether your gradient is right. Y minus 6 part is correct, x minus 4 part is correct. 5 over, yeah, that's right. No, yeah, that's right. Equation of BC, what Afra said was right. It was Afra, right?
Yes, Miss.
Yeah.
And CD, y minus 5 equal negative 2 x minus 12.
CD, y minus 12, x minus 12, those two pieces are right. Yeah, 5 marks, just like that. Others, do you see how easy this is? So when you, to find the equation of BC, the first thing you have to notice is that for the line BC, I already have a point on that line B. If I have the slope, then I can write the equation. That's what needs to come to your mind. So you only need to know the slope of BC. You know that BC is parallel to AD. So if you find and you have both coordinates of A and D, so you can easily find the gradient of AD, which would be the same as the gradient of BC. Then you're done. And then for the line CD, again, you have a point, then point slope form. You just have to know the slope. It's perpendicular to BC, where negative reciprocal. So beautifully everything connects. And if you have everything properly understood, it's very easy. Did everyone else get it? Let me write the two equations, BC and CD.
Yes, Miss, got it.
That's right, that's right. Just I will write them. So the equation of BC is y minus 6 half times x minus 4. The equation of CD is y minus 5 equals minus 2 times x minus 12, right? I mean, when you know one point, that point B was 4,6, na? So the that line that you had, like you had the line, whatever the line, you were trying to write the equation of that line. Already you know this line should go like y minus 6 equals, it's only the m that is missing, x minus 4. It's only this you have to figure out, and it is half. This point slope form is it comes in handy because it's, you only need one point on the line. And if you know the slope, then you can quickly use that format to write the equation. Okay, part 2, just 2 marks, coordinates of C.
Miss, I got 10,9.
10,9. Can someone verify that? C is 10,9? Yeah? Okay. So I hope everyone got that. 10,9 for C. That is the intersection point of these two lines. So you solve them. Yeah, so if you just go through some more questions, we'll do this little by little. So what we will do now, so we did 4 questions now. I hope you got a sense of how easy these are. Once you have your theory properly understood and lined up in your head properly, it's very easy. Okay, let's quickly, since we are on the topic of intersection, now that's what's going on in our heads right now, right? It's about how to find the intersection of two lines. That's what we did last. I'm going to connect it right there. This is not my usual flow. I'm going to change it slightly because I think this would be a better sequencing. I'm going to take up the next topic because we are we were in the topic of intersection of two lines. We'll finish it off, intersection of curves, okay? Put the next topic. So we are going into our note then. Do you have any questions or anything that you want to tell me, or any doubt or anything regarding these questions that we did now? Anyone? Because I don't see your faces, it's a huge, I really want to like see everyone. That lack of feedback from your faces, or that affects me a lot actually. No questions? Okay,
Yeah, miss.
silence means no. Okay, then your next topic, the intersection of, let me go to this and try writing here. Sorry, the intersection of a curve and a line. So earlier we did the intersection of two lines, right? And I said that what we did there can be generalized to the intersection of any two things. So when I say things, what other things could be there in on a like it's lines and curves. That's all. You can have straight lines. If something is not a straight line, it's a curve then. And there can be many different kinds of curves, right? Parabola, circles, weird looking curves, so many waves like sine curves. So the intersection of a curve and a line. You can even have the intersection of two curves, but you don't get that, okay? You only get a curve and a line. Even if you have curve and a curve, it's the same thing. The intersection of a curve and a line. Okay, right under that. Let me take another. Sorry. We saw how the intersection point, sorry, how the coordinates of, we saw how the coordinates of the intersection point of two lines could be found by solving their equations simultaneously. The intersection point of any two curves or a curve and a line could be found the same way. By solving their equations simultaneously. Okay, but in particular we are going to specifically look at the intersection of this we already saw in quadratics, the intersection point of a parabola. We are going to take specific curves. One is a parabola and a line. So this is a curve and a line, right? The topic is curve and a line. We take two specific examples. First one is when your curve is a parabola, so the parabola and a line, and when your curve is a circle and a line, okay? So put a subtopic, parabola and a line. Subtopic, how do you, let's put a little, oops, little heart. That's my, that's like my subtopic bullet. Intersection of a parabola and a line And if you remember, a parabola and a line could be in 3 cases. Oops. Ah, that's okay. Okay. Let me do. Oops. Ayo. Oh, wow. What happened? Oh, okay. I thought I lost everything that I drew. Okay, here are the different cases of intersection of a parabola and a line. You have seen this before in quadratics. Now I'm going to, when I say parabola, you know that a parabola can be upright or upside down, smiling or sad, whichever way. When you think of the intersection of a parabola and a line, there could be 3 cases. The line could cut the parabola at 2 points, at 1 point, and no points, right? So let me quickly draw the 3 cases. You can have a parabola like that. So I will draw 2, oops. I can't do it here. Nah? I have a blind, like dead spot. I have to leave some space there. And let this be my line. So my line could be cutting at 2 points. So then I will get, when I solve the equations, I will get 2 solutions. Or I could have it as a, oops. I can't seem to. Did this get stuck? Looks like this is stuck. Ah, okay, it's working. But I can't draw. Okay. Can you please draw it properly? Let me try it again on this side. Oh my goodness. Let me try this. Okay, like a tangent, right? So that's one point of intersection, 1 point of intersection right here. Or you can have your line go like that, no intersection, right? So these are the 3 cases. Intersection of a parabola and a line can have 2 intersection points, which means when you solve the equations, you will get 2 pairs of solutions. Let me write that. Yes, let's see, somebody is saying something. Senithu. I don't know whether this is a very primitive, no question is primitive, no question is, all questions are valid and important. But when we consider simultaneous equations, why do we sort of add or subtract the equations? Because there are common points for both. Why do we sort of add or subtract the equations? Because there are common points for both. I'm not very sure what you're asking, that the 2 parts in that line. So if you're asking why do we sort of add or subtract, I can answer that. What do you mean? Because there are common points for both? Okay, so let me just pause this right here and answer Senithu's question. The first part of your question is, Senithu, when we consider simultaneous equations, why do we sort of add or subtract the equations? That is a strategy of solving them, right? Now let me go to a new page. I'm sorry, others, this is all, and when you ask question, it's important that this is a good question for everyone to know the answer. Do you know why we add or subtract? So for example, if you have, oops. When you have, say, 2x plus 3y equals 9 and 5x minus 3y equals 4 or something. And when you want to solve these two equations, right? So there are two methods in substitution and elimination. Now, just if you just think about it, okay? If you have, when you have one equation of one unknown, if you have one equation of one unknown, like this, what do you mean by solving? Now you want to solve. You know that solving means to find the value of x that makes this true. 2 times what number plus 7 gives you 10. So you want to find that number that satisfies this, right? And that could be done by making x the subject. So you add 7 to both sides, you add 7 to both sides. Sorry, you take away 7 from both sides, you take away 7 from both sides, and then to find x, you divide both sides by 2, and you get 3 over 2. So the process was trying to isolate x, trying to make x the subject. That is one equation, one unknown. In this, you have if any one equation has two unknowns. Both equations have two unknowns. So you can't, then how you think, how do I solve this? But I have to think of both of them at the same time when I'm trying to find the values of x and y. So one thing you can do is, you have to think, can I combine these two and maybe get rid of one of the variables? And a nice way of doing that is by, so that you're supposed to have learned this in O levels. Maybe you missed to see this, okay? For the first time in mathematics, in O levels, in this topic, simultaneous equations, you learn that you can add and subtract equations. You add and subtract numbers, right? You add numbers, you subtract numbers, you add algebraic terms, 2x and 3x, you can add to say 5x. But do we add equations? That is something really new that you learned that came up in solving equations. Two equations can be added. It's like, I'll tell you, think of this, okay? You have one balance. It's balanced, right? It's balanced. It's in balance. It's in equilibrium. The two sides are balanced. It's one balance. There is another balance. Oops. See, I can't draw there. Let me draw the balance here. There is another balance. Again, the two sides are balanced. If I put this side and this side together, if I transfer these to this and these to this, I would get a new, would the balance go out of balance, or would I get another new balanced balance? I mean, can I do it? Would the balance stay in balance, or would it go out of balance? An equation is necessarily a balance. I have two expressions which are equal. So I have another equation which are equal. If I add the two sides, these two sides and these two sides, I get another equation in balance. You understand that? Right? So that is something that can be logically done. There's nothing wrong in doing that. You still get another equation, another balance, which is in balance. So you can still say this side is the same as that side. Two new sides now, two new weights, right? So adding equations is something that you learn it as something that you can do. Oh, I can add equations. So this side to this side, that side to that side, I get a new equation, and it's a valid, correct equation. So you use that in solving simultaneous equations. Knowing this, you don't just randomly add. If it doesn't, if it is not useful, you won't do it. If it doesn't take you to your result, you won't just do it randomly. You do it because knowing here, if I add now, in this example, if I add the two equations, left side to left side and right side to right side, the y is going to get cancelled, right? Now this is your balance, right? If I draw a line here to separate the two sides of the equation, I'm adding this to this, left side to left side and right side to right side. So, and I get a new equation, a new balance. And in that new equation, I don't have y. I get a simple equation like this with just x. So I'm finding the value of x that is keeping both these two conditions true. So I'm getting there, I'm getting to my results that I want to find. Similarly, you can subtract an equation from another equation. So that's a strategy of solving simultaneous equations. You add and subtract, you add or subtract the two equations that you have if you can get rid of a certain variable. Now here I have plus 3y, here I have minus 3y. So you can see that if I add them, the y will get cancelled. If you have the same y term, you subtract them to get rid of them. The purpose is to get rid of one variable. You add or subtract the two equations for the purpose of getting rid of one of the variables. And if you don't have the same variable, that's when you multiply one of the equations to make that term the same. Did I answer your question? I'm not sure whether I understood your question. Got it, right, okay. Please, I love it when you ask questions, and because I want you to have a complete 100% understanding of the mathematics that you learn. That is my purpose, okay? Not learn math for the sake, like a set of rules and just memorize some things. You have to improve your thinking. You have to be better thinkers. You have to be better problem solvers, okay? So you have to become better and better at it. So always, I encourage you to ask any question that comes to your mind. Okay, so getting back to this, when you think of the intersection of a parabola and a line, we are talking about the intersection of a curve and a line. I said we consider two cases, when our curve is a parabola and when our curve is a circle. That's all you have. But keep in mind, this knowledge can be extended to any two curves or any two things for that matter, okay? This is how you find the intersection point of any two geometrical objects. When I say objects, there are only curves and lines. What else is there, right? In two dimension. Right, so the three cases of the intersection of a parabola and a line are, you can be having like this, the parabola and the line cutting at two intersection points. Intersection, I hope you're writing with me. Two intersection points means when you solve your equations, you get two pairs of coordinates. Right? Or you can have I'm trying to manage the space here. You can have one intersection point, that means one pair of coordinate, PAIR, pair of coordinates or I will have to write over this. I'm gonna have to write over this. No intersection points. No solutions. Solutions. It's actually no real solutions. No pair of coordinates, no real solutions you would get when you solve, right? And I want to remind you another thing. Oops. Another thing. How do I get rid of that now? Okay, up, oops. While you're writing this, I want to remind you another thing. So if I give you the equation of a parabola and the equation of a line, do you remember that without going all the way to solving the two equations without completing the process of solving, there is a way of finding out at some point in your process, in your working, you can find how many points they are going to be. Do you remember how to do that? Before you even complete the solving process, there is a way to predict, this is going to have two solutions, or this is going to have one solution, or this is going to have no solutions. You remember how we can do that? We learned this in quadratics. I'm trying to get the chat, okay. In A1 or A2, will we learn about any other number line other than the real number? Yes, we will. And yes, we will. And that is your last topic in your advanced level whole syllabus. So it's at the end of P3. It's the last topic in P3. And it's the most important topic in mathematics for me. And I am always looking forward till we get to that lesson called complex numbers. Your minds are going to get blown when you do that lesson. It's a mind-blowing thing, learning about complex numbers. So yes, Aisha, you're going to learn another number line other than the real number line. Okay? Yeah, I'm glad you asked that, because we said no real solutions. Why do we say no real? Are there unreal solutions? We could have just said no solutions. Why do we say no real solutions? There must be a reason why we say no real solutions. We must be saying that because there are unreal solutions, isn't it? You're right. Yeah, there are unreal solutions. They're not unreal. It's a bad choice of term for it. It is very interesting, and I would, yeah. The thing is, for sure, you will do it. You will learn about it in school before you learn it with me, and I know that will spoil the experience, and you will not get that mind-blowing experience. I know it. But let's see. Okay, so you would do that lesson in school before you do it with me. Then I would ask you to take it away and do the lesson with me with a fresh mind. That's how I usually do it. Yes. I'm glad, Aisha. So she's doing privately, so she's not doing it in school. So that won't spoil her experience of learning the complex numbers. Yeah. Okay, both of you, right? Afra and Aisha. Okay, that's good. Because yeah, that's an amazing experience. When you learn about complex numbers, it'll wow you, okay? Right, so you didn't tell me, is there a way of predicting how many solutions we are going to get? If I give you the parabola equation and the line equation, is there any way that you can tell me, without solving them, is there a way that you can tell me that these two are going to have two intersection points, or one intersection point, or no intersection points? Can you find that beforehand? Anyone?
We can see the points of intersection, the parabola and the line on the graph.
Not by graphing. See, the graphs are not given, and you're not allowed to graph them. I just give you the two equations. That's all you have. You have the equation of the parabola. You have the equation of the straight line. No graph given, and you are not allowed to graph them to graph and see, graph and check. How can you tell me, without completely solving, whether there are going to be two intersection points, one intersection point, or no intersection points? Who remembers this? We did this in quadratics. No? Shall I tell them?
By solving the linear equation?
By?
Getting the values of the equation, the quadratic equation?
By getting the values. You mean solving?
Yes.
No. So I'm saying, so if you solve it You will eventually find out whether you're going, if you get two pairs of answers, you know there are two intersection points. If you get one answer, you know, that means there is only one intersection point. If you don't get any answers, you know there are no intersection points. My question is, can you determine that without solving? You have to do something, but not solving all the way. But before solving, there is a way of determining beforehand whether you're going to get two solutions or one solution or no solutions.
Using the discriminant?
Using the discriminant. Yes. The discriminant of what?
The quadratic equation.
Which quadratic equation? Okay, wait. So that's the next. Let me go to the page. Suppose I give you, now everyone, please listen very carefully. Say I give you two equations. Here's a parabola, x squared minus 2x plus 3. Okay, sorry, y equals, that's my equation of the parabolic curve. Okay, so in the equation I have a quadratic expression. If you remember this is a quadratic function. This can be thought of as a quadratic function, right? So this represents a parabolic graph. So I give you that, and then I give you a line, y equals 2x plus 4. How can you tell me? Is there a way that you can tell me? Let me label them 2, 1, and 2. Is there a way that you can tell me whether these two, now you don't know how they look like. You don't know whether, so the only thing you can say is that this parabola is a smiling parabola, and this line is a positive line sloping this way. That's all you can see. Until you graph, you don't know whether they are cutting or not cutting or how they are cutting. Who said that? Aisha said that you can use the discriminant. She said discriminant of the quadratic. Which quadratic?
A third equation.
The third equation. When you do the substitution here, like so, I can just make 1 equal to 2 here because I have y as the subject in both. I get x squared minus 2x. Sorry, plus 3 is equal to 2x plus 4. I get this single quadratic equation of one unknown, just with x or just with y maybe. It can happen either way. The discriminant of that quadratic that you get when you substitute, okay? It's not this one. Some people think it's this. So you might, because that also is a quadratic function. It's a quadratic function. It's not a quadratic equation. It has y in it, right? We're talking about this quadratic equation. It can be turned into the form ax squared plus bx plus c equals 0. So the discriminant of that equation can tell you whether you're going to get two solutions, one solution, or no solutions. If there is, so then you know how to determine. If the discriminant is positive, there are two solutions. If the discriminant is 0, there is you know the thing, right? So it's the discriminant of that quadratic you get. Okay, shall we write that here? Oops, did I lose? Okay, it's here. Shall we write that here? No, I'll give you the second case also, intersection of a circle and a line. For both of them, you can do that. The quadratic that you get when you substitute, you get a single quadratic. The discriminant of that quadratic, the third quadratic. Why do I say third? Because when you label your 1 and 2, it's like the third equation you get. So that the discriminant of that quadratic, the value of the discriminant of that quadratic could be used to predict or determine how many solutions you're going to get. Okay. Right. So we will write both of that together. So your first bullet point was this, intersection of a parabola and a line. Second bullet point, I will put another, can I change it here itself? I'm going to change. So you just continue your second bullet point, another star or a heart or whatever. I will say now, I will write it here itself. I will change this to intersection of a circle and a line, circle and a line. And I will change my diagrams. So again, can you think of a circle and a line? How many cases? Again, similar 3 cases you have. When you think of a circle and a line, the line could be going through the circle, cutting it at 2 points. You will have 2 intersection points, okay? Or you can have the line being a tangent to the circle anywhere, so just one intersection point. Or you can have your line, it's completely off the circle, so no intersection points. So let me draw that. Yes, there are circular graphs, and we are going to learn the equation of those two. Oops, I erased. Can I just erase that and that? Okay. So let me draw. After this, we are learning the equation of a circle. Yes. So one case how a circle and a line can intersect is, say you have your circle like that. So we draw 2 circles. And another circle. And let me take a different color. So you can have you can have your line cutting like that, or going like that, or going like that. So completely off. So in this case, you will have, here you will have 2 points. Here you have just 1 point. Here you have no points. So can you, this is your second bullet point. Can you write that? Now I just changed the same note. Please, you have to, hope you followed what I just did. You have it as a next, you have it as the second bullet point. Let me actually put 2 stars, okay? 2 hearts. Intersection of a circle and a line. Again, you can have 2 intersection points. That means 2 pairs of coordinates. You get 2 pairs of solutions when you solve, or 1 intersection point. I'm trying to get the chat box. Okay. Aisha is asking, for a parabola, we have the discriminant. Likewise, for a circle, yes, it's again, you get a discriminant. I'll show you how we get that. Because now you still don't know how does the equation of a circle look like? What kind of terms does that have? So you learn that later, but just we'll look at we're just thinking of the intersection here. And when you solve the equation of a circle and the equation of a line, there too you get a quadratic. Same thing, like a parabola and a line. The same thing happens. When you substitute, you get a quadratic. And the discriminant of that quadratic will again tell you how many points of intersection. So yes, it's the same thing. It's just like in parabola and line, with a circle and a line, the same thing happens. You get a quadratic. You're welcome, Aisha. So tell me when you're done copying. Let me also, circle and a line here, okay? Circle and a line. Earlier it was parabola and a line. Okay, Akitmi says done.
Done, miss.
Okay, then let's write that thing that I said about discriminant. I'll give this in a new page. When, let me make this large. When finding the intersection points of a parabola and a line. Oops, line. When finding the intersection points of a parabola and a line, and also a circle and a line. Sorry, there is a way in which we can determine how many intersection points are there, how many intersection points are there before in block letters, before we solve the equations. That is by using the discriminant. Now I have no way of changing the color of one word here, so I'm using bold letter, block letters. Discriminant. I think this is the discriminant. My spellings might be wrong. This is odd. Suddenly I'm not sure how to spell it. Has this happened to you? Like suddenly you don't know how to spell like a simple word like home, or maybe like school. This is a moment like that. I'm not sure whether I think it's DE. When you think too much, even the simplest things like this is what memory does to you. Yeah, there must be some psychological thing there. That is by using the discriminant of the, oops, not capital now, of the quadratic equation that we get after substituting. Equation that we get when we eliminate one variable, y, x or y, okay? When you eliminate either x or y by substituting, you get a quadratic. We are talking about that quadratic equation that we get when we eliminate one variable. And to remind you, I will write again. So if the discriminant, I will have to just write that like this. If b squared minus 4ac is greater than 0, the three cases are b squared minus 4. My goodness, my handwriting. 4ac is less than 0. So if this happens, this happens, this happens, what can you say? For the first one, 2 intersection points. Sorry about let me turn this. Points. Here, 1 intersection point. 1 intersection point. I hope you're writing with me. No intersection point 0. Intersection point. Okay. So remember, 1 intersection point means the line is a tangent. The line is a tangent. The word tangent should click to you that, oh, that means 1 intersection point. Or 1 intersection point means, oh, the line is a tangent. So that should be like the connection you should see. Okay, let's do a quick example. Do we have time? Yes, we do. Let's do a quick example. So you're going to learn in the next topic under coordinate geometry, which is circles. You're going to learn the equation of a circle. Right now you still don't know. I will tell you. If you're done copying, let me know.
Done, miss.
Done, okay.
Done, miss.
Okay. Shall we do an example? Right, example. 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 Find the intersection points. Find the intersection points of the circle. Here's the equation of the circle x squared plus y squared equals 8. Find the intersection points of the circle x squared plus y squared equals 8 and the line y squared plus, sorry, oops, x squared plus y squared equals 8 and the line y equals x. Find the intersection points of the circle x squared plus y squared equals 8 and the line y equals x. I think this is the first time you are seeing the equation of a circle. The equation of a circle would have, this is how you recognize it. If an equation is the equation of a circle, it will have a y square and an x square. Both y, the squares have to be for both x and the y. That is how you recognize that represents a circle. Okay. So how do we do this? We
Yes.
have to find, yes.
In the equation of the circle, is the constant the radius of the circle?
The square root of the constant is the radius of the circle. That's correct. When it is arranged in this form, if you have the constant term only on one side, the square root of that is the radius. We will learn that when we come to the equation of a circle. Okay. Right now, we are just focusing on how to find the intersection point. We are given two equations. The two equations represents lines and curves. We are finding their intersection points. So here, one is a circle and the other one is a line. And let's see, by solving this, what are the intersection points of these two are, whether they have any, one or two or none, and what they are. So you know how to solve, how to find the intersection points. We have to solve them simultaneously. So what can we do here? Sub 2 in 1, sub 2, because you have already y equals x, sub 2 in 1. So I will substitute for y in the first equation. So I can have x squared, and for y squared, I will have another x squared equals 8, isn't it? Because y is equal to x. So I'm putting this here, okay? I'm putting it there. So that is 2x squared equals 8. Then I have x squared equals 4. Then I square root both sides. I have x is equal to plus or minus 2. So I have two x coordinates, two points, that means. Then I can find when x equals 2, what is y? Ooh, look at my, that is because I'm sweating on my hands, palms.
Excuse me, miss.
Yes, Afra.
Miss, how did the second equation x become x square?
Not the second equation. I am substituting the second equation in the first equation. This is the first equation I'm writing. This equation, this one. So x squared plus I'm substituting for y. Y is equal to x now. Like this is y squared, for y I'm putting x.
Oh, okay, miss, got it.
You are correct. Or you
Yeah,
can,
I missed the substitution part.
right, okay. Or you can substitute y for x. Then you will get y squared plus y squared equals 8. Either way, both are right. So when x is equal to 2, y is equal to 2. Right? I'm subbing in 2. Ooh, excuse my handwriting, please. Let me remove all that. And it gets stuck now. Did I get stuck? I thought I was stuck for a moment. I was stuck. Sub in 2. So when x is equal to 2, when I substitute in 2, y is equal to 2. When x is equal to minus 2, y is equal to minus 2. So the two intersection points are 2, 2 and minus 2, minus 2. Okay? Got that? So this is a case where the line is going through the circle, cutting it at 2 points. Okay? Example 2. Right? Example 2. Are you ready to write the example 2?
Yes, miss.
Okay. Example 2. Determine without solving the number of intersection points. Determine without solving the number of intersection points of the circle x squared plus y squared equals 8. It's the same circle. Of the circle x squared plus y squared equals 8, and the line y equals x plus 4. And the line y equals x plus 4. Determine without solving the number of intersection points of the circle x squared plus y squared equals 8 and the line y equals x plus 4. What should you do? You have to do that first step where you substitute one in the other. You eliminate either x or y, and you have to get that quadratic, right? So let's do that. What's the easiest to do? Already you have in the second equation y is the subject, so you can substitute that. I can sub 2 in 1. Okay, so this I'm going to put for y here. That's the meaning. So what do I get? X squared plus, for y squared I get x plus 4 squared equals 8. Now that is my quadratic, right? I have eliminated y and I have a single equation which is a quadratic of just one variable x. So I have to find the discriminant of this. To do that, before that, I have to get this into the proper format. So let me square everything. X squared plus, here I get x squared plus 8x plus 16 equals, okay, let me bring the 8 also to this side, minus 8 equals 0. I get 2x squared plus 8x plus 8 equals 0. I can divide the whole equation by 2, isn't it? That would make my number smaller. I am going to divide the whole equation by 2. This is not absolutely necessary. I'm just doing it so that I have small numbers in my equation. X squared plus 4x, it's a good thing to do it. Plus 4 is equal to 0. Okay, now I am ready to find the discriminant. So I can continue this and solve, but they are saying without solving. So this is the point at which I can determine, without going ahead to complete the solving, this is the point at which I can determine, I can stop and determine how many solutions I'm going to get. By doing what? By finding the discriminant of this. So let me put a box around this. This is the quadratic equation of which I have to find the discriminant when I want to determine the number of intersection points. So let me write what A, B, and C are. A is 1, B is 4, and C is 4. Then, okay, I want to compute B squared minus 4AC. B squared minus 4AC is equal to, what is B squared? 4 squared minus 4 times 1 times 4. That is 16 minus, oh wow, 16 minus 16, that's 0. So the discriminant turns out to be 0. How many intersection points?
0.
1. Discriminant is 0 means there is 1 intersection point. Since B squared minus 4AC is 0, there is only 1 intersection point. Is that clear? So in this example, we were not asked to find the intersection points. We were asked to determine how many intersection points. So that requires only going with the procedure only up to that step until we get that quadratic, and you check the discriminant. Was that clear? Okay, Akimi, thanks. Hope it's clear to everyone. Please go over that note and that little bit of theory that we just discussed, and make sure that went to your heads very clearly. This is very important. Okay, we will have a look at a few questions where this little part, I mean, check using the discriminant to understand how many intersection points are there. We'll look at a few questions where that is tested next time, and we will learn the equation of the circle. We used it already here to find intersection points, but we will learn the equation of the circle next time, and maybe next time we might be able to finish coordinate geometry, and there is some